On-off, in other words, two-state inputs. Input signals are usually 24-volt DC. In some more expensive systems, other inputs, for example, 5 volts, 110 DC or AC, may be provided. But the most common is that they're 24-volt DC level inputs. To protect the internal workings of the PLC, so we don't want any kind of high spike voltages on the out. Okay. Output interface. This is the other end of the PLC that deals with the real outside world. All output signals to various actuators used on the equipment being controlled are connected to to that will read on that, and an extension unit will try. So terminals and makes a copy that can be off or on and memory. Yeah. So that we have stored in memory the current position of all the inputs. The next thing is that store image of any inputs that are changed. But it doesn't change yet. Yeah? When it gets transfers the stage of output states to the real outputs, and then it goes back day long while that PLC is running. It takes the same amount of time for routines and that kind of thing, but for the same consistent. However, here, so let's say 3 of our inputs are in this state, or input number. It then goes down here and does these 3 instructions, and it might use the state there that input is on to turn on output 3. It's going to have no effect yet. You've got to go all the way to the end of the program, transfer the output, so that output will turn on. It's going to go all the way that should but it can make that's high speed is called the same thing. All right, so just watch for that, and I think just about every student falls for it at some point in their program and career. We'll see. So I've summarised the main advantage is of the continuous scan cycle. It's like industrial networks. You know what your internet's like. 1 minute it's running at 2 meg, next minute it's down to half a meg or something. that have where it's or purport applications, but you should be aware an input signal should then approximately program asked to be missed. Okay, yeah, right. A little bit about contrast between traditional relay and PLC control. So this is like a small system where we got a hydraulic started and stopped on this contact. So that's our pump. We got to push that through the stop button, turns that contactor on, closes that contact, so the pump is running. And then the idea here is we have a stamp that puts, for instance, to stamp paint can or something, right? So you push the button here, through a limit, another relay that closes that, turns the stamp on paint tin, makes the limit switch, which breaks this circuit, opens that, spring return on, a fairly automated and this is our high. If in PLC stays exactly the same, still have contactor and valve, but all our switches to PLC inputs at the top. Yeah. P1, and it has the same function. Yeah. Do if you want to make changes you've got in your notes. I haven't got anything. If we that you push this button, we've got a problem. It's not always putting the lid on fully because it's making a limit switch and the cylinder's going back up again before the lid is fully home. We want to add a little time delay in so the cylinder goes down, hits the limit switch, waits half a second. On the relay system, we'd have to completely rewire, or not completely rewire, but break into the wiring, put a timer in, add an extra relay in. We'd have to cut a hole in the panel for the timer and so on, and rewire the system. Yes, we could do that quite amply. All we'd have to do in the PLC is add a couple of lines in the program. No physical changes at all. Now, a PLC update is not all no physical changes, because if you needed an extra input, another limit switch add-in, then yes, you'd have to wire it. But in some cases, it's just a matter of changing the program slightly to update. So there's advantage. Right, if we're going to go moving on, so we're now moving from that, how does it work, into our programming, right? So if we're going to build it, do anything more than the average OR and exclusive OR logic, we're going to need to use some internal relays, M relays. Yeah, so X internal M's. Mitsubishi PLCs have a large number of these. In fact, general type in FX3Gs that you're using, there are 384, and then we've got some fixed latch ones, of which there are 1,152 of, and then you've got another 6,000 general ones between M1536 and 7679. And the M8000s are some special function relays, of which you may use one or two of, and that 8,000 and above. There's 512 of them. They have a number of uses, two of which are simplification of complex logic, so meaning that you can put some complex logic into the action of one internal relay and then use that internal relay the rest of your program. Show you something on that in a minute. Also, the avoidance of double coiling errors. Okay, so where you've got two pieces of logic, you want to use parts of your program to switch the same output. You use relay two rungs and then those M relays to switch the actual output, avoiding the double coiling. More about that in a little while. So, using M relays to simplify ladder logic. Used to simplify complex logic and reduce the overall number of instructions. With large, more complex programs, they can also help you to create a more structured and simple to understand format. So if we had something like we've got on the left there in that blue cloud, some complex logic that confirms the machine is ready to run when it's true. So all the guards are closed, that kind of thing, and the machine's ready to go. Okay, we can send that to an M relay, in case I used M1. So this one is machine ready to go, guard shut or something. Now, as you can well imagine, you'd have a lot of points in your program where you might want to make sure that the guards are shut. What you can now do is put that M1 relay into your pump run circuit, into your operate press circuit, and you can even be closed one to say it's not ready to go because there's a guard open, and light a lamp. If you didn't do that part up there, this line up the top here, you'd have to put that logic in every one of those rungs, costing a lot of instructions, making your scan time longer, and so on, and making the program difficult to understand, because all this real logic for operating your pumps and your stamp and whatever kit you got has muddled in with all that stuff to do to make sure the guards are shut. Okay, so yeah, they're just like an output. They're like a relay output, but they have no connection with the outside world. You have to use them to switch other outputs, switch the Ys. Okay. Yep. The issue of double coiling. When programmed with ladder logic, you're not allowed to program an output coil more than in your program. Lewis. Right? Circumstance. I knew. Of what happens with. So, going to have a go at this. If on the next page, so you're going to get your PLC kit out in a minute and actually put this program in and see what can happen when you double coil. That way, you might recognise it when you accidentally do it. Programs. All right. So here's a possible solution to that. X0. See whether the run inch switch is turned on. One thing about that stop button is it's wired normally closed. So the X1 input is on when you haven't got your finger on the button. And at some point you'll get in a muddle with that. So that input is blue when you haven't got your finger on a button, and then it turns off when you push the button. And that's safety circuit standard, fail safe. If the wire falls off the switch or the switch is faulty, the machine stops or you can't start it. All right. Some people fall for putting the stop switch in there. The only thing wrong with that is that means you can put your finger on the stop. So stop buttons always go there. All right. That will, when you close that line complete, we'll turn that on, and it will land there, and then we'll. That is answered. That top bit. In green, we're going to answer the bottom bit. When X2 is off, and you push the button, The motor runs, but if you let go of the button, it stops. That is, in the first instance, a completely viable program for that specification up there. Yeah. Anyone might think that would happily work without any problems. Yeah. Our PLC kit.